Hi everybody. We're here to talk about a very specific aspect of one of the challenges that we had as we grew, on how to namely unify the existing environments with Java with the new environments and the new applications that were written in Python. We can also say that this is the presentation how we try to unify and what efforts did we have to take simply to make those apps be deployed, managed, and configured the same way. So we'll be both with Sviat talking on some technologies and developments that made Java and Python ops not only coexist in the same infrastructure, but being managed the same way. So here, as Java and Python are in this title, but expect only some code examples of Python. So we won't be covering anything about Java, but using Java as the legacy state of the infrastructure and showing you what we did in Python to move forward to something more modern, I would say. But let's talk a little bit about our history first. So Revolut started in 2015, and what it did at the beginning was something very basic compared to what it does now. These were namely currency exchanges and bank transfers. So from the technological perspective, what you look at, the thing that was in 2015 was mostly written in Java. Currently, in 2022, we have a much diverse set of both functionalities and the technological stack that we have. So Java is still there, but Python also plays a very important role. So currently, there are not only currency exchanges, transfers, but we have lots of features that simply allow you to manage your finance entirely, I would say. So this is called a super app concept, so essentially everything about your finance. So when you think about, let's say, streaming, or music, you immediately think maybe Spotify or YouTube Music. When you think about consumer electronics, it's Apple, and the theme here, so the idea here is to make Revolut the super app for your finance, anything about your finance. So loans, cards, crypto, stock exchange, and everything, namely. So, but it's also a nice place to work here and spend time. If you're interested to hear more, please talk to us just after this talk or throughout the conference. We have our own dedicated stand when we'll gladly talk about anything that happens internally in Revolut. So, I'm Tomek. I've been working here since 2021, from February. So, but in general, I've been working in Python since 2006. So initially, I used Python mostly in research and academia in analyzing some set of biological data using Python. So this field of science is called bioinformatics. But after leaving the research and academia, I just moved to regular software development stuff. So in general, I would say that since 2013-14, I'm mostly a regular Python developer working for different companies. So the story that we want to tell today is simply to show some of our efforts on including Python in the initially Java-only based ecosystem. So of course, this was not a one-time task. This is a continuous process as our platform develops. So what we're going to tell you is how we did that in a couple of cases. So I'll be talking about some selected technologies, selected developments that made this happen. So we'll also be overviewing some architecture of internal Revolut systems to just allow you to understand what's the general concept on how we process data and what happens internally that imposed some let's say, requirements from us to develop it. So let's talk about those two technologies. So Python and Java exist in Revolut for a couple of years now, but Java is the predominant language. So it's used mostly for backend development. And Python is not only used for backend development, but also for analytics, for reporting, for data science, for machine learning, many numerous applications. So as the company grew, the importance of Python also grew. So it became like one of those two main backend tools that we have. But Java is the language in which those first core functionalities were written, like card transfers, crypto exchange, currency exchange, and anything that was like the core business in 2015 and later. But when Python came, it came just to allow us to move to some more complicated cases that especially involve machine learning, analytics, data processing, reporting, and also we use it to develop APIs for internal services. We mostly rely on FastAPI as the tool that we use. We also used to use Flask. We also have some systems, internal systems like Revolut people, let's say, so the internal platform for managing people written in Django. So there's a lots of different technologies, but mostly in case of APIs, we rely on FastAPI. So Python developers in Revolut mostly implement business logic. So let's say credit underwriting rules or some different rules that need to be followed in order to realize some business process. But there's another dedicated team that also works on some low-level stuff, namely the platform team, which essentially provides infrastructure, tools, libraries for different teams that make use of those tools. So regardless how the application is built, whether it comes from Java or Python, it's essentially managed and deployed in a similar way. So of course we make use of containers, and those containers go to the cloud. So currently we make use of Google Cloud, but like we're agnostic of the cloud provider and could possibly deploy somewhere else, and we're using Kubernetes for that orchestration. So I guess most of you used containers, and in case of local environment, we of course use Docker and Docker Compose to simply spin up all of those services for testing and development. So how to do that? How to include the Python in the already existing Java-based ecosystem? Well, so that's the plan. So first of all, we need to talk and think how to make application configuration and then deployment done a very similar way, regardless of the technological stuff. So we need to also think about the general architecture of the services that we have here. So Revolut is mostly event-based. Anything that happens is an event. My colleague Sviat will be talking about that in a couple of minutes from now. But we also need to manage distributed transactions and simply be able to have the same configuration for the shared operations happening regardless of the language of our applications. So let's talk about first about how we configure stuff regardless of the language that we have. So we start with YAML. So YAML files constitute like the basic configuration for anything that happens inside Revolut. It's both infrastructure and applications themselves. So what we do, we have the automation that simply set up the cloud based on some YAML configuration, and based on that, we are able to quickly set up a new cloud if it is needed. So even if we make a mistake and the YAML is invalid, this change is not applied because automation takes care of that so that to validate those configuration files. But this is, let's say, trivial. In case of applications, regardless where they first come from, we need to build containers, then inject that configuration, so separate YAML configuration in that containers when they are spin up. So we have the image, let's say Docker image, and then container is created, and when it is created, somehow this configuration is injected. And I'll be talking about that in a couple of minutes. I guess you all are familiar with containers. If anyone hasn't just used them, it's a simple way of packaging your application, so it is just manageable as a concept of a single object, single container that contains everything, all the logic, all the code to run your application. So even if a change, again, a mistake is done in the configuration, the automation takes care of that it doesn't block the deploy. So the deploy is always done when the configuration is fine. Yet, on the other hand, if you can imagine when we connect with different microservices and let's say a password is changed, then we cannot directly check just by static verification of YAML files if a given secret, a given password is incorrect for one of those services that application requires. So we have some other functionalities to do that. It won't be explicitly covered here, but we also take care of that. So let's just focus on this part on the right, just talking about the application config, not talking about infrastructure config right now. So we can essentially have, this is a very simplified example, but there are essentially 3 different bits to take a look at here. So at the top, you see, let's say, the absolutely minimum configuration, so a simple YAML file with a single variable called environment at the top, which essentially contains some value. And at the below screen, we saw some code which simply allows to load this YAML file into Python object. So in Python, you probably know that there's this Pydantic library, which is an excellent tool for verification, for serialization and validation of the data. And based on that, we create the configuration of our apps. In Java, of course, there are some dedicated tools, but the idea is the same. Essentially to have a class that represents your configuration and is then used on the runtime. So it is simply instantiated, this instance of the config, as it can be seen here, by somehow providing, loading, or injecting some configuration read from the environment variable. So what happens internally is that the automation provides the running container with some environment variable, which contains a path to the YAML file, which is provided to the running container. So in this simple case, we would simply, this very simple application would print something on the screen that would relate to the environment in which it is running. So super important thing here is that if the validation fails, deployment will also fail at the early stage. So the application will be constantly available. So any mistake simply won't get into production. A little bit more complex case. In some cases, we can have separate configuration for databases. So let's say a database connection might require a name of the database, user to connect to the server, password, port, application name, and so on and so on. We might, of course, have several different configurations. Let's say one is used for one replica or master replica, another configuration only for read replica. So what can happen is that we can have it live in the same code. And what we use is we use the, let's say, dbconfig. So some internal Pydantic model that we have that corresponds to this configuration of the database settings. So it's used both in 2 places here. And this can possibly lead to implementing some CQRS. So one replica is used for write, separate replica for reads, essentially. Now, we talked about some application-specific configuration. So whatever your application does, if it is credit underwriting, so if you want to sell credit cards, if you want to sell anything or do anything, we have a specific application and specific configuration for that. However, regardless what your application does, it will most likely connect to other services. So there are some bits of shared configurations that are provided to any application running. And this is, for example, a configuration for shared HTTP clients. So what does it mean? So if you can imagine in a microservice world, we have lots of chunks, independent chunks of applications, as also shown on the previous talk, when we say split the monolith into several applications, they need to communicate. And this is mostly done using HTTP. So it is worth to note that it is worth having the same managed configuration of how we request data from internal services, regardless of this Java, regardless of this Python, or any application. And for that, regardless of having the application-specific configs, we can have configs specific for a given feature, like those HTTP calls. So two specific cases are circuit breaker and retry policies. So a circuit breaker is a thing similar to circuit breaker in electrical currents, so where it simply breaks the flow of the current. In the case of microservices, it stops calling a single or several microservices if anything wrong happens to them. So mistakes happen, and if the service that we depend on, let's say, dies, then it doesn't make sense to send further requests, but to somehow stop requesting it, and then retry in some other policy. So it is managed in a central way. So in this YAML here that you could see, we have, again, the shared configuration, which is provided by the automation, regardless if it is Java or Python application. Same with retries policy. If we are in the Python world, we can implementing retrying in many different ways. So essentially, it's trying to do something, catching exception, and just handling the exception. In case of HTTP, of course, we can have several policies. There is this fantastic library that you might know, which is called Tenacity, which provides that perfectly. There are different policies. Lots of them are also useful in case of distributed systems. But inside Revolut, we have our own approach to that. So in case of HTTP clients, we probably, in most cases, rely on the requests library. Do you know it? Have you ever used it? Is anyone who hasn't used it here? I guess not. Maybe if you haven't used it explicitly, there's a big chance that the tools or libraries that you were using was using it as well. It's one of the most popular Python libraries available there, and we also make use of it. However, we have our own approach on how to inject the reliability configuration. So the reliability configs that specify on what to do if bad things happen. So in this case, what we do is we have this get session function which creates request session. As you can see, one of the parameters to initialize it is to provide the reliability config. And again, the config is the YAML file that we could see, this short bit of, let's say, retry policy. So what should happen if a request cannot be sent? So in this case, we specify just the name of the service and the config, which is the instance of reliability config. So what we saw on the previous slide, like creating HTTP session and reading default config, is embedded in the base class that we can see here. So we have this import, let's say, HTTP API client, which essentially embeds some functionalities for handling connections to different services. So in this case, we have a user client, so a class which inherits from HTTP API client, which essentially represents getting data about a user from some resource. So how we do it in this case? We generally implement just the business logic or the logic of fetching that user data. So essentially, we fetch the URL path users, we specify the user ID there, we just get it, so this is the get method, and then we parse and then create the object. So when we talk about, when we take a look at those type annotations, so when we call it, we specify it as string, which is represented by user ID class, and we return the user, so the instance of the pedantic model. And for that to work, we, first of all, make sure that we always return user, so an instance of a class. Secondly, we use MyPy also to statically check the code to make sure that it is, let's say, somehow close to Java and its biggest advantages. Like Java is statically typed, static typing has lots of benefits, allows to detect bugs early, and we also use this approach simply to facilitate writing bug-free code. So from the business perspective, just to sum up, the crucial thing here is just to write the business logic. And how do we run it? We essentially use the user client, we instantiate it with some URL. The logic of accessing that URL is in the parent class, in the base class, and we provide the reliability config to it. Of course, this is a simple case. We are not showing here anything about authentication. We do have authentication in our internal services, but it's just like another topic that I don't want to cover here. So another aspect for common configuration shared between different services, regardless whether they are Java and Python, is, for example, logging configuration or traceability configuration. So let's say, in other words, we want to know what happens with a request originating in one app that goes to another app in our infrastructure and to the third app. We want to trace the entire request, how it goes through the microservice system. So what is this tracing? So essentially, it's actually HTTP header that is somehow added to the first request that passes along the chain of services being called. And as I mentioned, because we make use of Fast API, we have a dedicated middleware that essentially takes care of passing that request ID, that header throughout the chain of services being called. As Fast API is mostly deployed with UVcorn, the server, so we also have a dedicated configuration for the server that runs our application. So now we talked about configurations, so we have it configured. Let's think how we could deploy it, how we could centrally manage the deployment of our services. So we have a repository, as everything is stored in the code, which is called the technology governance. In the technology governance, we keep centralized configuration about all of our apps, regardless whether they are Java, Python, or iOS apps or anything. They are managed and described in a similar way. So in this case, this is an example of application from my domain, which is credit underwriting. So essentially, the application is provided some Python service template. It has defined some dependencies and the availability, so SLOs. But this single bit of YAML, which lives in some repository, simply specifies how the CI/CD pipelines are built automatically for it. So as you can imagine, iOS applications, Android applications, Java applications are all deployed in a different way. The same is for Python as well. There are specific ways of deploying them, but the configuration is kept in the same place. So let's sum up the first part before we go into more technical details. So what we've covered so far is the app configuration is a separate thing from the infrastructure configuration. You can simply keep it in the same way in repositories. In our case, these are the YAML files. And it's worth having common configuration for specific apps, specific aspects of your apps. Like in one place, you keep configuration of your application, and in another repository, you keep configuration of, let's say, HTTP clients or logging or anything else. Now, let's give a round warm of applause for my colleague Sviat, who is going to tell you about some other aspects of our architecture. There you go, Sviat.
Thank you very much. So, hello everyone. My name is Sviat. I'm actually in Python since 2017. I've joined Revolut in 2019, and a funny fact about me, that I've started my software engineering career when I was 11 years old, and I started this path from developing some server-side logic for different multiplayer games like Counter-Strike or Minecraft. Sorry for that. In this part, actually, I'm going to tell you in short how our services are communicating with each other, regardless whether they come from Java or Python. This will help you to understand how such big distributed systems as Revolut works and how are things happening there. First of all, I would like you to answer a couple of questions, and then I'll show you how we solve those in Revolut. So let's begin. How do you think what Revolut most frequent operation is? Sorry? Logging? No, but maybe let me clarify the question from the user perspective. Who said transaction? No one. So, as we are a banking institution, it's money transfer. Right. But there is unfortunately one trick. As my colleague Tomasz mentioned, we are event-driven. So there are microservices, a lot of microservices, and they are everywhere. Then, how do you think? What is the most challenging in microservices world? Yes. And if you actually recall from the previous part of our presentation, Tomasz mentioned something what is called distributed transaction. So, we have a lot of side processes, which part of them actually has to be run on every transaction. Such things as automated marketing, customer scoring, audit, or live fraud checks, for example. Some of those things are important to perform before the actual money transfer ends. And here we came with the solution. It's event sourcing. We are literally tracking everything what is happening to our systems, and let's see how we do it. What does event mean? Every time when something is happening in our system, we produce an event. It can be internal or external money transfer, a fixed rate update, user card top-up, and many more. We have a lot of events, really huge amount of events. And obviously, we cannot lose any data during distributed transaction. That forced us to use some techniques to avoid data inconsistencies and bugs in our distributed systems. One of such techniques is pattern called transactional outbox. Let's do some short theory before. This pattern actually gives us a guarantee of that all the changes, including emitting an event, will be produced in atomic manner. So let's take a look on example with money transfer operation. Our transfer service, as a part of local transaction, inserts all the changes made to a local entity in form of an event, of course, to an outbox table. Then, a separate message relay process publishes all the events inserted in outbox table to a remote message broker. It actually helps us to decouple service logic from knowing of how to proceed further with distributed transaction. We know that everything that was inserted into an outbox table always will be sent to centralized evil bus. Then all consumers can proceed with their part of distributed transaction. All events we are producing in a form of a JSON messages. Here we can actually observe an example of simple transfer event from previous slide. You can notice that there are model event type, event payload, and some transfer-related metadata. And now let's move to my favorite part. Let's finally take a look on some code example. How do we consume those events in Python? With actually usage of our internal shared library, developer has to define a consumer class with an appropriate config. It can be done just in couple lines of code. Here we see that we are looking for transaction, which was created, and its type is transfer. Next, in handle method, developer can implement required logic. It can be whatever. For example, some data analysis operation, sending an HTTP call, or just saving some parts of event for audit. Then, once logic is written, appropriate class has to be injected into an application entry point, as simple as that. So, let's conclude everything what we have seen during the presentation. We saw that on the first part, application configuration can be separate from application code and can live along with the infrastructure config. Common configuration for some specific aspects of your application like HTTP clients or logging can be easily shared between the infrastructure and projects which are written in Java in Python. And also it's viable to design system with a unified approach in mind for event-driven architecture that spans for both Python and Java applications. And also thank you for our main collaborators and developers, Dima and Artyom, who are working actually in Revolut. Thank for everyone who were listening to me and Tomasz. Yeah, and now we can move to a Q&A session. Thanks.
Thank you so much for the presentation. We haven't seen any questions on Slido. Maybe there are some.
But I actually heard that someone raised the question from this part.
Yeah, go ahead.
JVM shop, right? So my question is, when you run Python, do you see Python or do you run Python on JVM or some Graal to share? Well,
yeah, we use clear C Python.
okay. So you're using some alternative implementation, right?
So maybe the Revolut from because of historical reasons, everything was developed in Java. And in Python, we just had to use some wrappers to run a couple of different parts of code which written in Java using Python.
Written in Java using okay, that answers my question. Thanks.
So you can just think of it that we run native Python applications based on CPython interpreter. That's just make strong use of the Python best Python bits in the standard library and the custom libraries that we have. But those crucial parts that need to interact with Java or with any other language are, let's say, implemented using the native interface. In case of Java libraries, we have Java native interface, JNI, and in some cases, like the event parsing, we simply make Python talk directly to the Java library. So there's no like Jython requirement or Java implementation or Python or anything like that. No, it's like C implementation of Python that just makes you some library that exploits or uses the JNI, the Java native interface.
Another question from Slido. How is the wire transfer event aborted if, for instance, fraud check fails?
So actually, this one is very interesting because I also was interested in such things when joined Revolut. And the answer is very easy. So we are just doing the opposite transaction. You can just recall from your banking applications, for example, if your transaction is aborted or reverted by whatever reason, you have two transactions, upcoming and incoming.
Okay, thank you. Any other questions from the audience, maybe? No? Then, thank you.
Thank you all, and it also worth to mention that we have game in our booth, so you can win this thing, Nintendo Switch.